Thank you very much. It's exciting for me to give an update about this global project endorsed by SAGES. I spoke about it last year, and in the interest of time, I'll give a very brief summary over what a challenge actually is and what we're doing with the CVS challenge. Many of you know this functionality where you open your iPhone and it automatically classifies images and gives you background information about these images. What many don't know is that this was actually rooted in publicly available data sets such as ImageNet, one of the largest data challenges ever conducted, with a multi-million image data set by now and over 20,000 classes. This data set was assembled and then released to the public with a specific target task in mind. Initially, classification between cats and dogs, later expanded to object detection, localization, and so on. So a data challenge is ultimately a competition where computer scientists from all over the world compete in developing artificial intelligence for a certain target task on a publicly available data set. We translated this task, or we used this notion to create a global data set of laparoscopic cholecystectomy videos with the aim of developing AI for surgical safety in the operating room. There have been many data challenges in the medical field before, but I'm very excited to present an unprecedented data set today, focusing, as I said, on the critical view of safety in lab chole, not only clinically validated, internationally recognized safety measure, but also composed of 3 visually distinct anatomic features which surgeons target to distinguish and isolate in order to be sure that they do not clip the common bile duct instead of the cystic duct. This is the team behind the CVS challenge. Without each and every one of them, none of this would have happened. And I specifically want to point out my colleague Deepak Alapat in Strasbourg and my colleague Sarah Choksi, without whom we couldn't release the data today. What's so special about the CVS challenge? First of all, it's the first data challenge endorsed by a surgical society, building the bridge between large internationally recognized and established surgical and computational societies. Secondly, we target a clinically meaningful goal affecting surgeons and patients worldwide every day. We have an unprecedented data set of 1,000 laparoscopic cholecystectomy videos from across the world to offer to participants. And we aimed for an interdisciplinary approach with equal contributions by clinicians, computer scientists, and also industry representatives and input in order to ultimately, in a subsequent step, translate this into the operating room. And we developed a scalable framework that's suitable to host future challenges focused on different target tasks or even different procedures. And I'm very excited today to say that while for this iteration of the challenge we're releasing 1,000 videos, we actually, with the engagement and the effort of data donors from across the world, surpassed that goal and collected 1,500 operative videos. We had a interdisciplinary advisory board composed, as I mentioned, of surgeons, computer scientists, and industry. And together we developed a framework, a pipeline to make this possible. The pipeline consisted of 4 major pillars, one being data, the second being annotations, so labels to capture these target tasks, the ultimate task, so the ultimate goal of the competition that computer scientists then address, and then also the evaluation of their submissions. With respect to the data, we not only aimed for a large quantity of data, but also diversity to reflect the real-world population and the variety of patient and surgeon factors out there. A distribution close to the real world, not only with respect to the CVS achieved or not achieved, but different data attributes that I'll get into now. And obviously, we had to build a platform that enables donation data contributions from different regions in the world where different governing regulations capture and protect privacy regulations. So we build a portal where you can easily drag and drop your video, which then gets formatted and processed to be suitable for the challenge. And we ultimately achieved 1,490 with another 100 not on the server yet, from 70 surgeons, 67 institutions, and 58 countries. And I'm very happy to say that there's a contribution of 30% from middle to low income countries. Why is this so important? Why is this global contribution so important? So not only the data structure, as you can see, you see very different resolutions, very different operative conditions here for surgeons. Not only the data resolution and the formatting contributes to the diversity in the data set, but also different clinical factors, such as, is the procedure performed robotically? Is the procedure performed laparoscopically? Has fluorescent imaging been applied in the form of ICG? Or was there an intraoperative cholangiogram performed, which as surgeons gives us additional confidence in verifying the anatomy, but obviously a machine learning model will have to have that confidence without the information of the intraoperative cholangiogram. With all of that being reflected in the data set, we obviously had to filter this data very carefully and curate it very carefully. So the data was carefully reviewed by 3 different clinicians and then subsequently annotated by a large pool of annotators, again, recruited from 11 different countries to achieve consistent and objective annotations. And just being a good surgeon doesn't mean you compose a good data set. Annotations not only have to be clinically valuable, so reflect the CVS adequately, but also machine readable. Therefore, we had to redefine the definitions, the exact definitions of the critical view of safety in the form of a consensus-based annotation protocol, where many of the experts present in the SAGES community as well as EAS community contributed in the form of a Delphi consensus. This protocol is available on the website. And then we used this protocol to train annotators in a proficiency-based progression manner. So they had to first complete a data set of 60 videos and reach an inter-rater agreement of 70% with annotations that were actually derived from expert surgeons in the SAGES community. With respect to the tasks that we now present to the computer science community in order to fulfill this task of automatically assessing the CVS, the first, obviously, is the classification of the 3 criteria. On the left-hand side, you see the distribution of the first 4,500 frames, which we will be releasing today with respect to the CVS achieved. So we have a distribution close to the real world. The second task is a certain uncertainty quantification. We not only asked annotators, 3 different annotators per label, to rate whether the CVS was achieved or not, but we also asked them to rate their certainty, their confidence in assessing the CVS in this particular frame and video. We are now comparing their certainty with the model certainty. The model is now asked to quantify this uncertainty alongside the CVS. And as you can see from the graphs, these are the different certainties from annotators for the 3 criteria. As you progress to the right, and there was 100% confidence, annotators are more confident when they say the CVS was not achieved than the CVS was achieved. This could be linked to the nature of annotation being retrospective, there being less certainty when you don't have to make an executive decision. And lastly, robustness, and probably one of the most important tasks for this challenge, the ability to shift with the domains presented in the data. So the ability to generalize across different visual attributes of the data and also clinical attributes of the data. That's the last task that we offer in order to adequately reflect the complexity of assessing the critical view of safety intraoperatively and reproduce that computationally. The next task for us will be composing evaluation metrics or enforcing evaluation metrics that not only ensure technical accuracy, but also clinical accuracy. I talked about data splits and demographics a little bit. The challenge rules and evaluation metrics can be found on our website later today. And obviously, we also consider factors such as computational resources and access of different teams participating in the challenge, because we want to reflect that diversity not only in the data and the annotation, but ultimately also in the participants that contribute to this. Thank you very much, and I'm left with 33 seconds, so if we have time for one question, that would be great. Thank you.